Welcome to homework.
A convergent sequence is a sequence where the terms an have the property that limit as n goes to infinity of an. This limit exists and is finite. So two examples of that would be an equals 1 over n, where our sequence starts at n equals 1. So the first few terms would be 1, 1/2, 1/3, ... So this is definitely going to be a convergent sequence. This limit is 0. So the limit exists and 0 is definitely a finite number. Another example would be an is n over n plus 1. So limit as n goes to infinity of an. In this case, is just going to be 1. And again, 1 is something that's finite. And this limit exists. So that is also going to give us a convergent sequence. Divergent sequence is any sequence that is not convergent. Okay, so for example, the sequence defined by n equals n. So the first few terms are 1, 2, 3, ... Here we have limit as n goes to infinity of an is equal to infinity. So infinity is not finite. So this cannot be a convergent sequence. Therefore, by definition, it is a divergent sequence. Another example would be the sequence defined by an equals minus 1 to the n. So the first few terms would be minus 1, 1, minus 1, 1. And here, limit as n goes to infinity of an. This limit doesn't even exist. If the limit doesn't exist, then it also cannot be a convergent sequence, and therefore, by definition, is a divergent sequence. So a divergent sequence, the terms don't need to blow up to infinity. If the terms do blow up to infinity, then it will be a divergent sequence. But you can also have divergent sequences that are bounded, like this one, where the limit simply does not exist.